Morning or good afternoon, everyone. I'm glad you joined me here this morning to go over the road to continuous improvement. And today's topic is going to be process hazards analysis. And to begin with, I'm going to just start with a quick poll, just kind of ask you a simple question here. So the poll is, process hazards analysis is a concept that must be applied to both process safety management, or PSM, and the risk management plan rule. For those of you that might be from outside the US, you may not be familiar with the risk management plan rule, but that is the EPA, or Environmental Protection Agency's equivalent to PSM. So I'll give you just a few minutes to answer that poll. Yes, and that is correct. It is a true statement that EPA and RMP both require some type of hazard assessment or hazard analysis to be completed. So let's just kind of start out with what a PHA, or the process hazard analysis, is for those of you that may not be familiar with it. For example, it is really, the regulation requires that employers shall perform an initial process hazards analysis or a hazard evaluation on processes covered by this standard. The process hazards analysis shall be appropriate to the complexity of the process and shall identify, evaluate, and control the hazards involved in the process. Employers shall determine and document priority order for conducting the PHA based on a rationale which includes considerations and as the extent of the process hazards. This last sentence really has to do with when the PSM standard was initially promulgated. Facilities had so long to conduct their initial PHA, or process hazards analysis, of each of their facilities, and they had to be prioritized based on this criteria held in this last sentence here. So really the purpose and intent of the PHA is to identify potential hazards, identify or evaluate risk of those hazards, and then identify those safeguards or those entities that are put in place to reduce or mitigate that risk that was identified in your analysis. And then it's to apply safeguards consistently, and that's really the intent of the PHA element within PSM. So some of the common gaps that we see, and these are prevalent throughout all of our industries that we look at. I've conducted well over 250 compliance audits, maybe in the last 10 years or so. And these are the gaps that still persist today. The first one is the use of inaccurate process safety information, or PSI. Typically that is shown in P&IDs being incorrect. Whenever we facilitate PHA, we'll see, or somebody in the group will say, well, that's not how it really is out in the field, or that's been changed, etc. So we're looking at documents or P&IDs that do not reflect what is actually in the field. Unknown vessel design information. Again, that's part of the PSI function. If you don't know a vessel's design information, then it's pretty hard to determine whether or not hazards that you identify are truly mitigated with the equipment that we're actually using. Of course, unknown instrument design specification, incomplete or incomplete relief system design data, and then unknown ventilation system design data as well. So anything in the process safety information area, those are gaps that we normally see that are also reflect on what kind of PHA or hazard analysis that you've really completed. If the PSI is incorrect, the likelihood of your PHA being very robust and well maintained and identifying all of those risks is not very likely. Also, unknown safety systems and their functions and how do they actually work. You'd be surprised how many times I've conducted PHAs where I've asked, or somebody has made a statement, well, we have a system that mitigates this by doing this, and then I would ask, well, how does that work? the whole team will be kind of look at each other and say, well, I'm not sure how it works. So those things need to be documented in your PSI, obviously, before conducting the PHA. The next thing is unknown safety, and maybe it's how to mitigate the risk when we don't know. So how do you mitigate risk if you don't know how systems work? And then failure to address known industry hazards. Depending on your industry, there have been incidents in just about every industry that's covered by process safety management regulations. It's doing the research to find out some of those root causes. I know in the US we have CSB, or the Chemical Safety Board, that puts out a lot of good videos and a lot of good root cause and causal factors that are associated with those incidents. Those sort of things need to be incorporated in our PHA so that we understand how to apply those to reduce risk in our facility. The next thing is just the failure to identify and mitigate the risk. So if we don't have the right people in the PHA, for example, we might not even identify all of the hazards. And of course, if you can't identify hazards, then obviously we're not doing a good job in our PHA. Secondly is mitigating the risk. So even if we identify a hazard in our PHA and our team identifies that, making sure that we've taken the right steps to mitigate that risk is important as well. The last thing I have on here is a failure to address facility siting and human factors. And really facility siting has to do with a lot to do with siting of buildings, siting of control rooms, for example, maintenance buildings, et cetera, within the plant, so that you do not have ingress of toxic or ingress of flammable materials, or maybe you have the risk of a blast that could level a building or cause occupational safety and health concerns as well. The last part is the human factors. A lot of times we'll see in a PHA where human factors are considered just those things that people do by error or make a mistake. For example, they don't open a valve or close a valve by mistake, etc. Those really aren't the human factors that we're actually looking for in the PHA. What we're really looking for, in addition to those I just mentioned, is we're looking for things like fatigue, work hours, being able to get to certain parts of the process. For example, do they have to climb on a ladder to close a valve? And do they have to, for example, do they have 4 screens of active alarms that are always in? Do they have to page to multiple pages on the screen in order to get to address an alarm or a failure of some sort? Those are the sort of things that we're looking for in human factors. So characteristics of the PHA is obviously it's a crucial part of the PSM standard. It relies on accurate process safety information, and of course it does involve a significant time. So I've got another poll here that I'll just ask quickly. I can find it. One minute. Okay, we're going to skip that. I can't find that poll for now, so we're going to skip that one for now, and I'll come back to it here a little bit later as soon as I can find it. So some of the other characteristics we're looking for is it must be performed on each covered process. So you cannot take a PHA from one process and just copy and paste it into another. They have to be performed on each covered process, even though those covered processes may be similar. It must cover the entire scope of the process. In other words, where does a PSM coverage end, begin and end? And it has to encompass all of those things, plus those pieces of equipment that may be pulled in, that may not be interconnected or anything else, but they're close by, and they need to be addressed as part of your PHA as well. They should cover all equipment and all components. And of course, they must be revalidated or redone every 5 years. The PHA reports for every process must be retained for the life of the process. Typically, the PHA team, for those of you that have done PHA and very familiar with PHAs, you understand all of this. They must be performed by a team with a required minimum of 3 people. So they can have various roles within engineering and operations, and they must be and should be your most experienced and knowledgeable people in the process. Being involved in a PHA should not be a form of punishment, and actually it should be an area of prestige where if you're on the PHA team, that's an honor to be on those teams, because you have very good knowledge of that process, and you can bring a lot to that exercise to reduce and mitigate risk of your processes. Of course, the PHA must address equipment in the process, hazards of the process, identify any previous incidents, and then look at engineering and administrative controls. We talked about facility siting, and there's some good consensus standards to look at. RIGA-GAP is API 752, 753. Must look at human factors, and then you must do at least a qualitative evaluation of safety and health effects. That's the minimum requirements. So there's several methodologies that are out there, and I'm not going to go through every one of them, but for the most part, the most popular ones we see today are the hazard and operability study, or HAZOP. You have the what if, and then you also have the what if checklist. So it combines the what if analysis with a checklist of some sort. And then you have the failure modes and effects analysis, or FMEA. And then others, of course, are fault tree and bow tie. Those are the most common ones you see in our industries today. The HAZOP methodology is a process, is a team approach. It's a collective brainstorming effort that stimulates creativity, new ideas. The team should have varying backgrounds and expertise, and it really is a structured and detailed analysis, and that has the best analysis for a well-defined system as well. So in the PHA HAZOP, you have a process that creates deviations from the process design intent by combining guide words such as no, more, and less with process parameters, resulting in the possible deviation from the design intent. For those of you that have ever been involved in a HAZOP, you know that these guide words are typically no, more, less, as well as reverse and other than. And then the parameters are flow, temperatures, pressures, composition, phase, level, relief, instrumentation. These are just some of them. It's not all of them. Typically, a facilitator will go through these guide words and parameters prior to the actual team getting together to kind of pre-populate their database and using the correct guide words. So if you put a guide word together with a parameter such as no and flow, we all know what no flow means. We all know what no pressure means, or no level means. We may not know what no composition means, but we may understand what it means to have more composition of one thing more so than the other, etc. So the guide words and the parameters have to be determined usually beforehand, and you eliminate the ones that will not make any sense for that process. So the what if methodology is the next one we're going to talk about. Is essentially it's a brainstorm of possible hazards of what can go wrong, formed in a what if kind of question. For example, I have here off to the right on a piping general checklist here. So what if piping leaks? That's the question that we would may form in a what if methodology. The last thing we have here is the what if checklist methodology, and essentially that's what we have in the piping general there to your right. It's a checklist of all potential things that we've come up through over the years that may be potential hazards or deviations that we might see as a result of asking what if type questions when it pertains to piping only. We have, for example, I think 50 pages of checklists that we can actually go through in a checklist format. Sometimes the what if checklist can actually be more robust than the PHA HAZOP method when used correctly. A lot of times we will use the checklist method when it pertains to changes that are not significant enough to go through a complete HAZOP. For example, we'll do a checklist. Typically, you will use this checklist to help develop the HAZOP nodes and the HAZOP guide words that we'll use, because these checklists are maintained based on industry hazards that have been pointed out in incidents, et cetera. So we will maintain this checklist and then use it in the HAZOP development as well. So in a PHA, we have different terminologies that we use. We say a deviation, we have a cause, we have a consequence, we have safeguards, and then we do risk ranking and recommendations. Now, some of these PHAs, and especially when I facilitate a PHA, for example, I like to risk rank twice. So I like to risk rank before I apply safeguards, and then risk rank again after. When you risk rank prior to safeguards, then you can really look at what that safeguard is actually doing in terms of mitigation. So many times I will see in PHAs, people will list all of these safeguards, and then when you start looking at them, they're not independent, or they really do nothing to mitigate the risk at all. And when we start applying good methodologies for defining what a safeguard is and defining how much risk reduction those safeguards actually contribute, then we can see what real risk reduction we're really getting. So a deviation is a depart from the design intent of the process section. So if we're looking just at a reactor, for example, we're just looking within that section itself, first of all, defining what is the design intent of that reactor, what temperatures, pressures, flows, etc. And then we're looking for deviations from that design intent. And this is where the PSI obviously comes into play again, making sure that our design intent, our safe limits are well defined within our process safety information, so that we can pull that information in for the team, and making sure that they understand the design intent of that section. Of course, any deviation has to be realistic, and there has to be sufficient, they are sufficient in their realistic causes as well. And of course, in a PHA, a team judgment is used predominantly. So the bigger the team, a lot of times it's harder to come to a consensus on whether an item is realistic or not, but it shouldn't really matter. It should really just kind of quick poll to say, well, is it realistic, is it not? And if it's not, then move on. Must also look at external events. For example, weather, floods, tornadoes. You know, in this day and age, we have to look at security issues, et cetera, within our facilities as well. So those external events should and need to be a big part of our PHA, no matter where we're at. Then what we do is we look at, sorry, that got a little bit further. Then we must look at the consequences of those deviations. What potential effects do they have on our process? For example, do they result in release of hazardous flammable materials? Do they result in equipment failure? Do they result in structural or operational failures? And then general system failures as a whole. We must define what those consequences are and being realistic on what is the worst case that can occur. Then and only then, like I said, when I facilitate PHAs, what I would do at this point in time is I would risk rank based on the deviation and consequence. What would be the risk associated to our facilities if we added no safeguards, if we had nothing in place to mitigate that deviation and resulting in that consequence. Once we've done that, then we can start applying safeguards, and usually safeguards are features designed to prevent the cause or mitigate the consequence of deviation. Included when the PHA team determines the cause and consequence, presents a credible process hazard. And then only if you can only add a safeguard if the PSI can be verified as correct, and the potential safeguard has been inspected and tested to ensure they work as intended or designed. I can't emphasize this point enough. I see this every PHA that we look at when we do a compliance audit. we will actually pull those safeguards and listed safeguards for consequences and deviations and consequences that result in personnel injury or some health and safety effect. We will pull that safeguard and we will ask for the process safety information, and then we'll ask for the inspection and testing. And currently, about 76% of the time, they will not have those inspections and test records, sometimes not even have the PSI, but yet it's listed as a safeguard in the process. So safeguards really have, when you're looking at process hazards analysis, we're looking at 3 different types of safeguards. Actually, you have a business and asset protection. Usually that's an operations sort of safeguard. Also, you may have environmental safeguards that keep environmental incidents from occurring. The last thing we're really looking at is process safety and employees. Typically, that's where we're typically looking at from a process hazards analysis when it comes to PSM. We're looking at process safety and how it affects employees. That does not mean that we cannot address the business and asset protection and environmental. That needs to be determined prior to the PHA as to which safeguards and where you're going to list safeguards, how we're going to do a risk mitigation, whether it's just on process safety issues or if we're going to do it on environmental and business assets as well. When it comes to process safety for employees, we're really looking at 2 different types of safeguards that we can apply. We have safety controls, alarms, and interlocks. And then we have non-instrumented safeguards like dikes, containments, those sort of things. So some more SCADA or safety controls and alarms and interlocks. You have safety alarms, you have permissives, you have safety instrumented systems or SIS. All of these are distinct different safety controls and alarms and interlocks. You also have safety critical controls. A lot of those may be some type of interlock that you put in place to keep a certain event from happening. Hopefully, most of you that are here today are familiar with this Swiss cheese model, where we're talking about managing how you manage your safeguards through layers of protection. Each of these slices of cheese, if you will, a Swiss cheese, as we know, Swiss cheese has holes in it. That's the same way with our safety systems. Our safety systems all have holes, whether they're inherently designed into those or just something that we were not aware of could be a potential cause. So if we look at those holes as being potential failures in that system, if something goes wrong and the device doesn't work as it was intended or designed, then we may have another layer of protection behind that that will stop that bad or major event or accident from occurring and catch that error in that system. So the more layers of protection they have, obviously the more robust our risk management systems are, and also the more reduction in risk that we can actually see in our systems. So the other thing is, of course, in our PHAs, we're always looking at risk reduction, and most facilities will use what is called a risk matrix. And essentially, we're looking at, in the matrix, we're looking at consequence or severity versus frequency and the likelihood. So as we define the severity of a consequence, we may assign it, for example, we could assign it to a level 4, which would be a C on the matrix. And then we're looking at a frequency. How often will that event likely happen? Again, prior to doing a PHA, you must define what this risk matrix looks like. What is severity, and define what severity really means. What does frequency and likelihood mean? Does one represent maybe once in a lifetime, or does it represent once in 100 years, 1,000 years, or 10,000 years, etc.? So prior to doing the PHA, a well-defined risk matrix must be defined, and then the team can use that to determine risk for each of the hazards that they identify. Of course, if the risk, resulting risk, even after applying safeguards, is not enough to reduce the risk down to a level that's acceptable, then you must recommend additional protection. Recommendations should follow hierarchical controls principles, and then the resolutions or recommendations should be completed in a timely manner as well. So a recommendation priority, and this is just best practice, is high priority action items should be resolved within 4 months. And those are the action items that are very severe, and the likelihood is high. So within 4 months. Medium priority action items should be resolved within 4 to 6 months. And then, of course, the lower priority action items should be resolved following the medium priority items. As we said a second ago, we said all recommendation action items and safeguards, and when we apply them, should follow hierarchical controls. And first thing we ought to do is, obviously, if we're following the hierarchical controls methodology, is look for ways to eliminate the risk. If we can't eliminate it, perhaps substitute or replace the hazard with something less hazardous. And then apply engineering controls. Engineering controls are things like interlocks and safety instrumented systems and alarms, et cetera. Those are the things that we're looking for in engineering controls. Administrative controls are usually those things such as procedures, et cetera. And then the last thing that we should be looking at is additional PPE when it comes to mitigating risk to our process. The other important thing to keep in mind is after the PHA is complete, you must implement the engineering controls that you defined. And engineering controls at that point in time become critical. And in other words, that means that now those critical controls that you added must be tested and inspected. You must have all the process safety information in place, et cetera. Testing and inspections typically within a year. If it's the CIS, could be more often than that or less often than that. The process safety information typically will define how often and how frequent those testing and inspections must be done. And of course, you must implement all high and medium recommendations as soon as possible as well. So some of the best practices that we see is first of all, conduct PSI reviews periodically. In other words, don't wait 5 years to start your PSI reviews. Oftentimes we'll get a call from a client and say, well, we want to do our PHA next month. And I will ask the question, I said, so when's the last time the PSI has been reviewed? And are you certain that your PSI is accurate and up to date? And they will say, well, we haven't looked at it from the last PHA. So those are things that we recommend, that you take a certain percentage of your PSI annually and you review it and correct it. Out of that, you should be able to review your management of change processes if the PSI is incorrect. So if you're having issues with P&IDs being incorrect or PSI not up to date or been changed, et cetera, then you need to go back and look at your management systems as a result of management of change to make sure that you make those corrections. Again, use the best people for the PHA team. Use your best knowledgeable people on that team always. And then, of course, review industry incidents. And like I said, there's a lot of resources that you can use to get that information from those resources as well. Use a facilitator that does not have ties to the facility. Oftentimes we'll see in audits is when we look at a PHA, and we'll see a lot of gaps or holes or issues that had not been addressed, hazards had not been addressed. Those usually come from a couple of different areas. One, the facilitator did not have the knowledge and experience that they needed to be able to facilitate that PHA. Or two, they had the knowledge and experience, but they might have been the engineer of the facility. And of course, sometimes when you're directly involved, you may not make the recommendations that you need to make because that becomes work for you. So we usually like to see people removed, facilitating that are removed from the process, have really no financial responsibilities, have no direct responsibilities with the process itself. We also recommend, from a best practice standpoint, is you conduct a complete PHA redo every 10 years. And what that means is essentially the PSM standard does allow you to conduct a reval. And a reval essentially going back to the initial PHA and just revalidate that nothing has changed. And you can continue to do that throughout the life of the process. However, we recommend that at least every other PHA that you completely redo it. If you go back to processes that were the PHA was conducted back in 1993, 1994, those PHAs were pretty bad. You can look at it and say that, well, there just was not a lot of effort, there was not a lot of knowledge applied to the PHA, and the methodologies that have been developed since then, and hazards that been addressed since then, and known hazards that have come about since then weren't applied. So if we're only doing a revalidation in the initial, then we can't capture all of those new hazards that we have been able to find throughout from the time of the initial till now. The last best practice, use a third party to audit the PHA processes. And we're not just talking about just auditing your PSM, but auditing your PHA processes to make sure that your processes are as robust as they need to be, making sure that the right people have been involved, make sure that you're addressing all of the hazards, make sure that the risk mitigation is really occurring, or you're really addressing all of the risk and hazards in the process. The next thing that they should be able to do is help you making sure that you've identified safeguards that actually have all your process safety information in place, that they've been able to track and maintain the PSI, maintain those systems the way they should be. The next thing is we need to look at is what are the next steps. So we looked at kind of the gaps. We kind of went on a quick overview of what PHA is, and we just lightly touched on everything here. So just to address those things and best practices again, review your process safety information. I always suggest that that people pull a PHA, a couple of pages out of your PHA, grab some of the safeguards, and go out there and ask the question, do we have the process safety information for that safeguard? And then two, do we have the testing and inspection records for that safeguard? And is it operating in the way that we said it was operating, and we've documented that somewhere? If we don't have that information, then maybe it's time to go back and say, let's redo this PHA with that information corrected and brought up to date. Again, select a facilitator that understands the process, understands the process that you're actually using methodology, but also understand a process in general. What do you do? Are you a refinery? Are you a chemical plant? Are you a gas plant, et cetera? All of those things have some general knowledge to make sure that they can help you address and pull out the information from the PHA team to address the various hazards in your process. Again, take into account industry incidents. Like I said, CSV is a great resource, but also API has some great resources as well that you can count on to get past industry incidents and those causal factors and root causes for those incidents. Also consider using a semi-quantitative method for addressing risks. For example, LOPA, and there's others out there, but LOPA is the most common, layers of protection analysis, or LOPA is one that's predominant. Set risk tolerance criteria. A lot of facilities do not understand that they don't have to put it in every safeguard as possible to reduce it down to a level A all the time. What they have to be able to do is develop their risk matrix so that they understand what their risk tolerance is. If they want to mitigate everything to as low as reasonably possible, then that needs to be set in their risk tolerance criteria. And for example, there could be one facility that could take a loss of $10 million or more. And then you have a smaller facility where that number now is 2 million. They could take a loss of 2 million or less. So that is the risk tolerance, and what kind of risk that are they willing to take. If you have more money, obviously your risk tolerance is a little higher than somebody that has less, et cetera. And of course, depending on where your facility is located, if your facility is located out in the middle of the country, very few people surrounding it, and then your risk tolerance can be a little bit more than if that facility was located around lots of people. Don't assume risk is mitigated just because you have a list of safeguards. And this is what I see quite often, is people will tend to list a lot of safeguards, but they really haven't mitigated the actual risks of the consequence that they've defined. So I'll kind of open it up now to questions. If you want to ask me any questions here, we can certainly open up the mics and let you all ask a question. If you don't have any questions, then we'll just end it here in just a couple of minutes. Okay, well, thank you very much for joining us today, and please join us next month, or actually later here in May, where we're going to be talking about operating procedures and applying the same principles to those as well. I hope you join us then. I hope you got some information out of this today that you can go back and apply to your facilities and get better at reducing risk. And really, that's the whole idea behind the PHA, is to reduce and mitigate risk in our industry. And when we do that across our industry, then our industry certainly gets better, and we don't have that stigma of people looking at our industry and say, well, they kill a lot of people, they don't do any risk mitigation, and really we do a good job of that. So please apply your PHA knowledge and experience, and please don't hesitate to reach out to me if you have any questions at all. And if we can help you achieve further risk mitigation, we'll be glad to help you. Thank you all, and have a great day. Thank you.